So, you're very welcome to this Saturday session with Exam Revision on Leaving Cert Chemistry. We will begin this live session in just a moment. In this Saturday session today, what we are going to look at is we are going to explore first principles calculations for your titrations, which appear in question 1 of the Leaving Cert exam paper. We're also going to revise and mainly focus on the ethanoic acid titration. So we will revise the key theory that's associated with that, and we'll also complete then the calculations for this experiment, and we will go over 2016 question 1, which is an ethanoic acid exam question. So the first thing that we need to know is question 1 on the Leaving Cert exam paper will always be a titration question. There are a wide variety of titrations on the Leaving Cert Chemistry course, and they come from the chapters of water, acids and bases, which we will see some from today, and oxidation and reduction. Question 1 will always consist of a mix of theory and calculations. When we're talking about theory here, we're talking about theory specifically related to the experiment, but we're also talking about titration technique. So that could refer to the preparation of any piece of equipment, such as a burette, a pipette, or a volumetric flask. It will also maybe look for indicators, and you may also be asked for colour changes. Also, we are seeing in recent years that the last part of this question 1, they're pulling from the origin chapter, I suppose you could say. So for acid and bases, for example, with the ethanoic acid titration, they're pulling a question based on ethanoic acid from your organic families chapter. With oxidation and reduction, they're starting to bring in some reference to oxidation number, and for water then they're pulling theory from there as well. So it's just important to know that although the titrations are in question 1, you do need to have a little bit of a background on your theory of the titration that's in question and the chapter that it originates from. So today, for example, we will be looking at our ethanoic acid, which will be a carboxylic acid family. So you should know some theory around the carboxylic acids and their properties from your organic chemistry chapter. A top tip that I have for question 1 is that you most certainly will need to know how to complete calculations by first principles. Up to a few years ago, you were able to use a formula to complete these problems. However, in recent years, the formula has not been able to be used, and you needed to approach the question through first principles. First principles will work for all titration calculations, even those that the formula can be used for. So it is a smart choice to pick first principles. You are cutting down on the amount of learning that you need to do, but also you are showing a better understanding of how the calculations in the Leaving Cert Chemistry course, and particularly in your titrations, actually work. So first principles is very important. The next thing I would say for question 1 is it is important to read the questions carefully, as answers will need to be specific and to the point. As with all questions in the Leaving Cert Chemistry paper, there is no real room for waffle when it comes to questions. You must get to the point, answer what has been asked, and be as specific as possible, because from looking at marking schemes you will be aware that certain words on the marking scheme are highlighted in bold, and without those keywords you don't get the marks for your question. So it's important to be specific and to the point. The next thing I would say to you is you should underline the keywords and action verbs of all your questions. So, for example, you may be asked to state something, you may be asked to describe, you may be asked to identify. These are all different action verbs, and they all have a different way of answering them. So state and identify are quite similar. All you do is write down the answer, no need for an explanation. You literally just give the answer you're asked. A lot of those state and identifies will come with colour changes. However, if you're asked to describe means you need to explain, you need to give some steps, you need to give background, you need to show understanding. The describe questions will usually be worth somewhere between 12 and 15 marks. And what I always say is 1 point in a Leaving Cert chemistry paper is equal to 3 marks. So if your describe question is worth 12 to 15 marks, you should be writing somewhere between 4 and 5 points at least. Your state and identify might be worth 3 or 6. So depending on what's been asked there, you can figure for yourself how much you need to write, but it should be short and to the point. Now, as I said previously in this video, titration calculations should be completed by first principles, and you've only been able to use the first principles approach in recent years. Even if you are able to use the formula approach, which I will not discuss in this video, you will still be able to complete it by first principles. So first principles is the smart choice for your calculations, and I would say it is the only choice if you want to be getting a H1 in Leaving Cert Chemistry. If you don't learn first principles and you rely on the formula method and it doesn't work for you, or you're not able to complete it, you are automatically dumping your titration question and you won't be able to answer it. So the smart choice is to go with first principles. Now, as you can see down below, I've created a flow chart for you which goes through the steps of first principles, and these steps are very clearly laid out. As you can see above it, it tells you in the boxes, the coloured boxes, blue and red, it tells you what each step is used to find. And below in the white boxes is then it tells you how to complete each step. So for example, if you're asked to find the moles of your standard solution per titer volume, you would use the formula moles per litre, or the molarity, divided by 1,000. The reason you're dividing by 1,000 is because it's moles per litre, and there's 1,000 centimetres cubed in a litre, and you're multiplying by your titer volume. Now, one year it did ask this moles of your standard solution per centimetre cubed. So what you would do here is you would just divide by 1,000 and not multiply by anything. So it is important that when you learn these rules for first principles, that you can see that they are flexible and that you can interchange them, but that they are the basis of all of the answers to your questions, and that you will be able to answer questions using these set of steps, but you just have to read carefully in case there's any edits that you need to make to your formula and make them accordingly. And we'll see that in a few minutes when we complete the 2016 question. Step 2 of first principles then would always be to find the moles of your unknown solution in your titer volume. And to do that, you use the ratio, or the moles ratio, from your balanced equation, and you would compare your standard solution to your unknown, check the ratios. But the important thing with this step is to be careful of your volumes and that you use the correct volumes for your unknown solutions and your standard solutions. And we'll see this, as I've said, again in our 2016 question that we're going to go through in a few moments. The last thing then for first principles, and this is usually what the question will ask, it will ask you to find the molarity of your unknown solution. To find the molarity of the unknown solution, you need to complete the first 2 steps of first principles and then fill your answer in, moles by 1,000 divided by the titer volume, to get molarity. You're dividing by the titer volume and multiplying by 1,000 because you're looking for molarity, and molarity means moles per litre. Now, this should make sense to you from class and school. If it doesn't and you're still slightly confused, keep watching because we're going to do a first principles calculation and I will take you through it step by step to help you understand. So touching on just what I said a few minutes ago about knowing the theory behind the experiments and also where they originate from, the experiment that we're focusing on today is the amount of ethanoic acid that is present in vinegar. So this is obviously linking into your carboxylic acids, and we know that our carboxylic acid has a functional group of COOH. So you should know that a carboxylic acid, the functional group will always be at the end of the chain, and that is because of the OH group that is present in your carboxylic acid. As you can see here, we've got our OH group, which is our hydroxyl group, and our carbonyl group of our C double bond O. Our chemical formula for ethanoic acid is eth, so 2 carbons, so it's CH3 COOH, and this would be the structure of it. CH3 COOH. So that is just a little bit of a background on carboxylic acids, their functional group, where they are, the functional group is usually positioned on the chain. And then, of course, the carboxylic acid that we're interested in today is ethanoic acid. And I've drawn that in for you there on the bottom left-hand corner of the screen. So the particular titration that we're going to focus on in this video today is the ethanoic acid titration. And what we're going to do is we're going to determine the concentration of ethanoic acid that is present in vinegar. Now, when I'm doing titrations, I like to condense everything down into what we need to know. So this box here that we can see underneath our title is very handy to know what goes where in your titration, what is in your burette, what's in your pipette and your conical, what your indicator is, and what your endpoint or your colour change is. This is handy to know so that when you're being asked about how you would prepare your equipment for the experiment, you can use the correct solutions that you might be rinsing with. And we'll go through that in a few minutes when we get to our exam question. So in your ethanoic acid titration, in your burette, you're going to have ethanoic acid, and it is going to be of unknown concentration because that is the solution that we are going to be finding the concentration of. In the pipette and the conical flask, you are going to have a sodium hydroxide solution of known concentration. So we would be able to say that the sodium hydroxide is our standard solution because we know that a standard solution is a solution of known concentration. And you're going to have 25 centimeters cubed of your sodium hydroxide standard solution in your conical flask. Reminder when you're talking about pipette, etc., that you need to make sure that you include that you're using a pipette filler. And just to go back to the burette, that when you're filling the burette that you use the funnel. So there are just a few extra little pointers to help you along the way. The indicator for this experiment is phenolphthalein, and the phenolphthalein is always added into your conical flask. And the colour change that you're looking for is pink to colourless. So that means that your phenolphthalein is pink in a base and colourless at the end point of the experiment where all of the base has reacted completely with the acid and our solution starts to turn more acidic. It's important to remember in all experiments that an acid and a base will give you salt and water. And the balanced equation for this experiment, I'll write it on the top for you. So I just put it in a little blue box for you there. It's CH3COOH plus NaOH goes to CH3COONA plus H2O. And finally, one of the most important things to remember in this experiment is your dilution factor. You need to look out for that because the vinegar will probably have been diluted before you use it. So in this experiment, when you're doing calculations, you will be looking at a diluted version calculation, and then they will also refer to it. They will refer then in a second part of your calculation to the original solution, and the original solution is the concentrated one, and that is where your dilution factor DF will come into play. So just to keep an eye out for that in your calculations. So let's take a look at an ethanoic acid titration exam question, and this question has come from 2016 question 1. So what I would recommend that you do is, at the very start of the experiment, I would be highlighting my CH3COOH in one colour and my NaOH in another. And I would highlight the volumes and any figures that are got to do with those two chemicals in their specific colour. So if we start to read through the question, it says, to determine the concentration of ethanoic acid in a sample of vinegar, 25 centimeters cubed of vinegar, so that's our ethanoic acid, 25 centimeters cubed of vinegar were diluted to 250 centimeters cubed. And then the diluted vinegar was titrated against a previously standardized solution of 1.20 grams of sodium hydroxide, so that's my sodium hydroxide, so that would be in blue, in 500 centimeters cubed of solution. On average, 18.75 centimeters cubed of the diluted vinegar, so that's yellow there, were required to neutralize 25 centimeters cubed of my sodium hydroxide. So there we can see what I've done in the first block is I've extracted all of the information that I need to know to potentially do my calculation, and I have highlighted them in the specific colours. Then when it comes to first principles on whether I'm doing my standard solution or my unknown solution, I know what colours or what figures I am looking for. The second thing I would say to you here is this first line, 25 centimeters cubed, apologies, 25 centimeters cubed in 250 centimeters cubed. That tells us that we have a dilution factor of 10, because 25 centimeters cubed, you can fit 10 portions of 25 centimeters cubed into 250. So in that first paragraph there, we've gotten a lot of information for our calculation, and it is important that we highlight and know what all of that is. Next, you can see we have our balanced equation, and with the balanced equation, one of the key things that you should be noting here would be your ratio of your two reactants. So I can very clearly see here that this is a 1:1 ratio, and I'm putting them in the correct colours. That will be helpful also for your first principles calculation. So let's go down now and actually read what the questions are asking. So the first one, I can see here, I'll highlight this in green. Our first keyword or action verb is describe. So it says describe in detail the procedures involved in measuring 25 centimeters cubed of vinegar and diluting it using deionized water. So I'm going to highlight that in yellow because again, it's 25 centimeters cubed of my vinegar in 250 centimeters cubed. So I know when I am completing the description of this question, part A, that I will be looking for to use my vinegar. Also, we can see here that this question is worth 15 marks, so I would be saying that the marks for this would be 5 by 3, so you need at least 5 points in order to gain full marks in this question. Part B then, it says to name the indicator and what is the colour change that's observed at the endpoint. So naming the indicator, very simple, and what is the colour change? A keyword there would be change. Change means that you need to give the before and the after. So just to be aware of that, because a downfall that students have is they just say it goes and whatever colour it is. You need to give the change, so you need to say what the colour is before the titration and at the end point. We can see that that's worth 9 marks, so that would tell me that the indicator would be worth 3, naming it, and the colour change would be worth 6 because you have to give 2 colours. Then we can see parts C and part D are got to do with our calculations. So if we look, it says calculate, that's our keyword. And here they're getting you to calculate the number of moles of sodium hydroxide. So sodium hydroxide, our standard solution, in each 25 centimeter cubed portion. So that is the number of moles of your standard solution per your titer volume. So that's what we would expect to get. Part 2 then says the number of moles of ethanoic acid, but a key thing here is it's per centimetre cubed of the diluted vinegar. So the key part here would be that it is per centimetre cubed. So just to be careful, that will affect your second step of your first principles just slightly, but we'll come to that in a few minutes. Part D then, it asks you to find the concentration of ethanoic acid in the original vinegar. So I would straight away, when I see that, I would be thinking part D, I must be including my dilution factor. What you're asked to calculate the concentration of the ethanoic acid in the original vinegar in moles per litre and as percentage weight per volume. Now, percentage weight per volume, just to remind you, percentage weight per volume is simply referred to as grams per 100 centimeters cubed. So when I see that I'm getting moles per litre and then I have to get grams per 100 centimeters cubed, I would also be indicating here I'm going to have to do something along the lines of my molecular mass. Part E then says, starting with a primary standard solution of anhydrous sodium carbonate, what 2 titrations are required to standardise a sodium hydroxide solution. So that's coming from your theory and your understanding of your different solutions, and we'll answer that question in a few minutes. So that's breaking down the question, and it's very important that you do that at the start of every question that you do in the Leaving Cert Chemistry paper, as it will make the question a lot more accessible and you will be able to fly through it a lot quicker. Also, by looking at the question, you can see that the majority of the theory and calculations here, by looking at the colour scheme, is centering around the vinegar. There's only one calculation on your sodium hydroxide, and the rest is all about the vinegar. So that's important to look at as well. So the first part of this question that I'm going to do is the theory parts of the question. And the theory parts of this exam question are parts A, B and E. So let's go through part A together. First, part A asks you to describe in detail the procedures involved in measuring 25 centimeters cubed of your vinegar and diluting it to 250. So this is looking at your vinegar and how it would be diluted down. This question is worth 15 marks, so we're looking for a minimum of 5 points, as I have said on the previous slide. Now I have this typed out, so I'm just going to show it on the screen now, and we'll go through each step separately. So, to answer this question, you would need to give the following steps. I've given 6. I would always give an extra step in order to ensure that you're going to get full marks in the experiment. So because this is 15 marks, you need a minimum of 5. So I've given 6 here just to cover you. So you have to describe in detail the procedures of measuring a 25 centimetre cube sample of the vinegar and diluting it with deionized water up to 250 centimetres cubed. So the first thing that you need to do is you need to rinse the pipette with deionized water and the solution that it is to contain. So that helps to maintain the concentration of the vinegar so that it's not diluted from the outset. To do this, you would use a pipette filler to fill your pipette with your 25 centimeters cubed of your vinegar solution. Next, what you will do is you will transfer this 25 centimeters cubed from your pipette into a volumetric flask that has been previously rinsed with deionized water. Now, you do not rinse this with vinegar. You don't rinse the volumetric flask with vinegar because we are pipetting 25 centimeters cubed of vinegar into our volumetric flask, and we want to ensure that we have exactly 25 centimeters cubed in there. So that's why the volumetric flask is only rinsed with deionized water. When you are draining your pipette, you do not blow out the last drop, and this is important because the pipette is calibrated for this. So even though you might see a little bit of vinegar left in the bottom of your pipette, it is calibrated for this, and exactly 25 centimeters cubed has been expelled from your pipette already. Once that's done, you can fill the volumetric flask with deionized water until the bottom of the meniscus is in line with the graduation mark. And that line is key. That line is used in every single titration that you will do. The bottom of the meniscus should be in line with the graduation mark. It's important to remember that when you're filling with deionized water and you come close to the bottom of the meniscus, you should add dropwise using a dropper. And once you've that done, you invert your volumetric flask 20 times to create a homogeneous solution. And that is describing in detail how you dilute your vinegar and make it up to a 250 centimetre cubed solution. So the next part of this question, part B, asks you to name your indicator and your colour change. So the indicator, it says name, so that means you're just going to name it. And they're looking for a colour change. So when they're looking for a colour change, you need to ensure that you give 2 colours, and I said that on the last slide. So our indicator in this experiment is phenol phthalate, and we know this from our pH and indicators chapter because this experiment involves a weak acid, which is ethanoic acid, and a strong base, which is sodium hydroxide. The colour change then is pink to colourless, and we've discussed this in our previous theory already on this experiment. Part C then says, starting with a primary standard solution of anhydrous sodium carbonate, what 2 titrations are required to standardise your sodium hydroxide? So what's been asked here is what 2 titrations do we need to do in order to get a standard solution of sodium hydroxide, i.e. to figure out its concentration before we start. So the first thing is we can note from the question that we are starting with a primary standard solution of anhydrous sodium carbonate. And if something is a primary standard, we can know its concentration from the outset. So what you would do is you would take the anhydrous sodium carbonate solution and you would titrate it against a strong acid of hydrochloric acid. And this would allow us, by calculation, to find out the concentration of the hydrochloric acid. And then what you can do is you can react this hydrochloric acid that you now know the concentration of, you can react it with some sodium hydroxide. And that will enable you then to figure out the concentration of your sodium hydroxide, thus creating a standard solution of sodium hydroxide. It will have been standardized as per the question, and you will know the concentration of it. So that's worth 5 marks, and that there is bringing in your pH and indicator chapter. It's also bringing in your acids and bases chapter, which links into what I said earlier. You do need to know the background of chapters in order to be able to fully answer these titration questions. So that's all of the theory in this question. So let's move on to the calculations. So to begin, let's take a look at what the questions are asking us. We're going to take them step by step. So the first question here in our calculations in part C, it asks us to calculate the number of moles of sodium hydroxide. So sodium hydroxide we were marking in blue in each 25 centimeter cubed portion. Now, what we need to do here is, from the outset, we need to write down, because we're dealing with our sodium hydroxide, a smart thing to do would be to write down all of the information that we know about our sodium hydroxide so far. So we know for our sodium hydroxide that we have 1.2 grams of it, and it's dissolved in 500 centimeters cubed. Now, we currently have grams per 500 centimeters cubed, and we want to go to moles per 25 centimeters cubed. So first thing we need to do is we need to go and we need to convert the grams to moles. And we know to go from grams to moles that we can divide by our molecular mass. So the molecular mass of our sodium hydroxide, I'm just going to do it on top here, the molecular mass of NaOH is equal to 23 for your sodium, 16 for your oxygen, and 1 for your hydrogen. So that is 40. So we can take our 1.2 grams then, 1.2, divide that by 40, and that will give us 0.03 moles per 500 centimeters cubed. And what I can do with that then is I can multiply that by 2, and that will give me 0.06 moles per litre. And once I've gotten it into moles per litre, I can now go and do step 1 of first principles. And step 1 of first principles asks you to find the moles of your standard solution in your titer volume. So you need to do the molarity, which we know is 0.06. You need to divide that by 1000 because it's currently in moles per litre, and you need to multiply by the titer volume. And the titer volume, as we can see in our question here, is 25 centimetres cubed, so we are going to multiply that by 25. And when we do that, we get 0.0015 moles per 25 centimetres cubed. And that is step 1, or part 1 of this calculation completed. Now, as you can see very obviously there, by knowing first principles, you are very easily able to complete this part of the calculation. So if we go and look at C part 2 now, underneath, C part 2 is asking you to calculate the number of moles of your ethanoic acid. Now, ethanoic acid, we know is in yellow. We said per centimetres cubed of your diluted vinegar. So it's important here that you're looking at per centimetres cubed. Now, I know that we know the concentration of our sodium hydroxide, so we want to figure out the concentration of our ethanoic acid. So once I know the concentration of one of my solutions in my titration, I can then go and use the balanced equation and look at the ratio. And that is step 2 of first principles. So as you can see here, the moles of the unknown solution in the titer volume, that is what we're trying to do. We're trying to find the number of moles of our unknown. Our unknown here is ethanoic acid. Now, instead of per titer volume, we're looking at it per centimetre cubed. So we'll get to that in a few minutes. So we can use the moles ratio from our balanced equation to figure out this solution. So we know that from our balanced equation, we have CH3COOH is to NaOH. So we know straight away that that is a 1:1 ratio. Now I'm sticking to the same colours for my base and my acid. So I know from the previous part that I had 0.0015 moles of sodium hydroxide per 25 centimeters cubed. Now, this part here, when we're using your ratio, you're working with your titer volumes. And from our question, we know that we had 18.75 centimeters cubed of your ethanoic acid was required, or your vinegar was required to react with the 25 centimeters cubed of your sodium hydroxide. So first of all, because it's a 1:1 ratio, the number of moles will be the same, but the volume will be slightly different. It's 0.0015 moles, but it's per your titer volume for your ethanoic acid is 18.75 centimeters cubed. And that's what I was saying earlier about the importance of the volumes. You have to check your volumes accordingly to ensure you use the correct ones. Now, that's not what the question asks. The question asks us for the number of moles of ethanoic acid per centimetre cubed. We currently have it per 18.75 centimetres cubed, so all we simply need to do is divide 0.0015. We can divide that by 18.75, and that will give us 0.00008 moles per centimetre cubed, and that is the answer to part 2. So if we move on to part D. For part D, you can see that we are dealing with the original vinegar. So once we see straight away that we're dealing with the original vinegar, we need to start thinking about our dilution factor that we're going to be using. So part 1 of our part D says to find the concentration of the ethanoic acid in the original vinegar, and that needs to be done in moles per litre. So this again is vinegar, and it's going to be done in moles per litre. Now that is step 3 of first principles, because what you're being asked to find here is you're being asked to find the molarity of your unknown solution, and the vinegar was our unknown at the start. So we can fill in, we currently have moles per centimetre cubed, so we can fill into our formula here, and I'm going to do this in yellow. So we know that we have 0.00008 moles per centimetre cubed. So instead of dividing by the titer volume here, I'm dividing by 1, because I know it's 0.00008 moles per centimetre cubed. So that's just divided by 1, and I can multiply that then simply by 1,000 to get it into moles per litre. So that will give me 0.08 moles per litre. However, that is for my diluted vinegar. The question asks for it for my original, so I must multiply by my dilution factor, which I figured out in the previous part of the video, is to be 10. And how I got that to be 10, my DF, I'll write it up here, DF equals 10, because what we have is we have 25 centimeters cubed in 250. So we know that is a dilution factor of 10. So that will give me 0.8 moles per litre in my original sample. So that is D part 1 done. So now we can look at D part 2. And for D part 2, they are asking you for it in percentage weight per volume. So percentage weight per volume, to remind you, I've mentioned this already, and I'm going to do this in green because, no, I'll do it in yellow because it's for your vinegar. Percentage weight per volume. Percentage weight per volume basically means grams per 100 centimeters cubed. So I currently have moles per litre. So I need to get that into grams per 100 centimeters cubed. So if I have 0.8 moles per litre, there's 1,000 centimeters cubed in a litre, and I want it in 100, so I can multiply that by 100, divide by 1,000, and multiply by 100, and that will give me 0.08 moles per 100 centimeters cubed. Now, the last thing you want to do is get that into grams. And to go from moles to grams, you must multiply by the molecular mass. So I need to find the molecular mass of our ethanoic acid, which is CH3COOH, which is 12 plus 3 plus 12 plus 16 plus 16 plus 1, which is 60. So I can do 0.08, multiply that by 60, and that will give me 4.8 grams per 100 centimeters cubed, which is 4.8%. And that is your answer to D part 2. So as you can see here, for C part 1 and 2 and D part 1, you were just looking at your first principles, and they just split it up into 3 separate parts for you. And this is a prime example of where you would not have been able to use the formula method from years ago, because these were separated into separate sections. You wouldn't have been able to use it. So that's why I strongly recommend that you use first principles only in your titration calculations. D part 2 then, that came from the stoichiometry chapter, where you were asked to convert from moles per litre to percentage weight per volume, so that should come with good practice. So hopefully this lays out the exam question for you in a nice way that you can read it and go back over it. So that's where we finish our exam question for today, and where we finish our theory around the titration, particularly at the amount of ethanoic acid present in vinegar. So just before we finish up, I just want to show you what the Leaving Cert Chemistry exam revision website looks like. So as you can see here, I have all the units of the Leaving Cert Chemistry course done out for you. Units 1 to 11, and there's also a folder there on exam preparation. So for example, if we click into the oxidation and reduction section of Unit 6, we can see that I have 5 videos here on all of your oxidation reduction titrations. Those videos go through the experiment, the method, common exam questions, and any calculations. And there's also a Leaving Cert Chemistry sample solution done out for you for an exam question of that experiment. You can also see that there is a self-correcting quiz, a PowerPoint presentation, and of course the H1 standard notes. There is also an area where you can build your own exam to test yourself on the titration questions or any part of the Leaving Cert Chemistry course, and marking schemes are also provided. So the standard plans on ExamRevision.ie are $19.99 a month, and premium plans are $29.99 a month. And for today, on this Saturday session, if you wish to sign up to a standard or premium plan for Leaving Cert Chemistry with Exam Revision, you can use the discount code LCChem20, and that will get you 20% off. So if you need any guidance for Leaving Cert Chemistry, don't forget you can get in touch with us here at Exam Revision. We're on Twitter, Instagram, TikTok, Facebook and YouTube. And of course, you can visit our online learning platform, ExamRevision.ie, where you will get access to the full Leaving Certificate Chemistry course done out in video format, H1 standard notes, PowerPoint presentations, and of course self-correcting quizzes and access to previous exam papers. So that's it for today's Saturday session. Thanks for joining in, and hopefully we'll see you at the next Saturday session very soon.